Good morning. This is Ms. Billerbeck, and we're going to talk about section 5.4, fractional equations. So the big difference between what we've been doing is we've been doing fractional expressions. So expressions don't have equal signs, but equations have equa, which is equal in Latin. So we have the only difference is this little old equal sign. So they all have an equal sign, and that's what makes an equation. When we have an equal sign too, we're able to do a few more things than we normally do. So we are able to do cross multiplication when we have an equal sign. So what cross multiplication means is exactly what it says. We do a cross. So we multiply those and those. So we multiply across the diagonal. So we would have 3x minus 1 times x plus 4 equals 2x plus 5 and x minus 3. Now we have to be really good with our FOIL because this one is just easier with FOIL. So we're going to do first, that's 3x times x is 3x squared. Outer, 3x times 4 is 12x. Inner, so negative 1 times x. And last, negative 1 times negative 4. Then we do it again. How fun. FOIL, FOIL, FOIL. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Then we have 5x and negative 15x. So we have just done some FOIL. Okay, so we have to simplify. So we're going to put a little S in the SAM process here. So we have some like terms. That's why we're simplifying. So we have 3x squared. This one, 12x minus 1x is 11x because we add those coefficients. And then minus 4 equals, and we have 2x squared. And look, we have some more like terms that we need to add. So negative 6 plus 5 is negative 1x. We usually don't write the 1, but I'm going to for now, just because we're simplifying and going to be doing additive inverses and all sorts of things. So we have minus 15 here that drops down. Okay, so we finished simplifying. Now we're going to use an additive inverse. So this is bigger than this one, so let's move this one over by putting a negative 2x squared using an additive inverse there and putting it over there. So we have x squared plus 11x minus 4 equals, that's 0 now. So we have negative 1x minus 15. Now we can move this over there. So the opposite of a negative 1 is a positive 1x. So we put a positive 1x here, and that's another additive inverse. So we have x squared plus 12x minus 4 equals, and that's 0, and we have negative 15. Well, we're not even done, and we need another board. Okay, that's the way this lesson is going to go. So on this one, I have too many boards here. Okay, so on this one, we need to move this 15 over, so we're going to use an additive inverse again. And we're going to do a plus 15 plus 15. So if we do it on this side of the equal sign, we have to do it on this side of the equal sign. It's like there's this balance bar here going on. Okay. So we have x squared plus 12x, and then negative 4 plus 15, or 15 minus 4, is plus 11, and we have equals 0, and that's what we were going for. We were trying to zero one side out. So if it asks us to solve for x, we have to use a really fancy process called the diamond box process. So I'm going to teach that to you right now. So that's A, that's B, and that's C. And it's really important to have this ordered in the highest to the lowest degree. So this x squared is the highest degree. The 2 is higher than the 1. Remember, there's really a 1 there. And remember that there's really an x to the 0 there. And we all know x to the 0 equals 1. So why write it? Okay, so then we have right here for the diamond, we're going to multiply A times C, and down here we're going to put B. So 1 times 11 is 11. Okay, and then we have just B, 12. So now we have to think, what multiplies to be 11 and adds to be 12? If you said, oh, that's simple, it's just 1 times 11, you would be totally correct. So 11 times 1 is 11, and 11 plus 1, or 11 plus 1 is 12. Sorry, I was going backwards. 1 times 11 is 11. All right. So now we use the box. Now I taught you how to use the box the other way, but today we're going to use the box from the inside out. You can do it. I know you can. So we have x squared right here. So the first term goes here. The last term goes right here. Now that's where these fun things, these nice new numbers that we found go. So we have 1x here and 11x here. All right, so now we look at common factors because we're trying to remember how we found the area of each one of these squares and added it up, and that equaled that factored. So now we're going to find what those factors are. So 11x and 11 have 11 in common. This column only has x in common, and we're going to put a plus there. This has x in common. We're going to put a plus right there. But this one, it's a strange one. We have 1 times 1 and 1 times 11, so it just has a 1 in common. So that's the greatest common factor. So now we know that this factors as x plus 11, x plus 1. Okay, so we use the diamond box. We can use it in our special cases that you learned, and we can also use it in the not so special cases like this one. All right, but if we notice that these two parentheses, when they're multiplied together, it equals 0. So that means either x plus 11 equals 0, or x plus 1 equals 0, or both of them equal to 0. So those are our solutions, perhaps. So we're going to set x plus 11 equals 0, and we get x equals negative 11, and x plus 1 equals 0, and we're going to subtract 1, and we get x equals negative 1. So the moral of the story is the solution for this long problem that started way back when with this problem right here, the one we've been working on for all this time. That negative 11 in here will work, so it'll make this equal to that. Oops, I wrote this down twice. That's a 1. That's why we don't use pencil in math. Everybody makes a mistake. So we're going to put a negative, if we put a negative 1 in here, that would also make this true. So there's two different solutions to this problem. So sometimes we don't just get one or no solution or infinite solutions. We might get two, or we might get more than that if it's a higher order polynomial. Okay, so let's go to the next problem. So that problem we did cross multiplication, but sometimes we have problems where we don't just have two terms, we have three terms. So in this case, we're going to use the ninja fraction busting technique of multiplying by what is in the denominator. So I have an x and an x minus 2. So I'm going to multiply by x and x minus 2. And I'm going to do it on this side too, because I can't just do that to one side without doing it to the other. Okay, so now I write out what I have just done, x minus 2, x plus 2, and that's going to be over x. And then I have plus, and that's going to be x times x minus 2, and then I have the 1 over x minus 2, and this one's 2x times x minus 2. Well, now we can see some things are canceling. So this cancels that, and this cancels that. So now we have no denominator. Yay! Oh, and hey, look, we know what that is. X minus 2 times x plus 2. That's the difference of squares formula, which is x squared minus 2 squared, which 2 squared is otherwise known as 4. So we have a much simpler thing to write here, and then plus, and the only thing that survived this cancellation was x. And then if we distribute this, we have 2x squared, and then 2x times negative 2 is minus 4x. All right, so if I'm going to start moving things around, this one's bigger, so I'm going to move this one around to over here. And this really has a 1 in front of it, okay? We just don't write 1s very often unless we're making a point. And I'm making a point right now. So we have negative 4 plus x equals, and 2 minus 1, well, that's 1. So that's just x squared minus 4x. So I used an additive inverse. All right. So this one, now I'm going to move this one, this x, over here. And I'm going to put a 1 right in front of it, too. I'm going to use an additive inverse again. So that gives me negative 4 plus 0 equals x squared. And negative 4 minus 1 is negative 5x. Okay, we're getting there. So now I have to move this one last 4, and I'm going to move it over here using an additive inverse. So I have my little balance bars going right here. So that makes this side 0, and I have x squared minus 5x plus 4. So if I put a 1 here, I've got an A, B, C, and it's in order from the highest degree to the lowest degree. So now I'm going to do my diamond box. I have A, C, and B here. So 1 times 4 is 4, and B is negative 5. So I have to think what times what equals positive 4 and adds to negative 5. And then I realized, oh, That's just -1 and -4. Because -1 times -4 is +4, but -1 times, or -1 plus -4 is -5. So sometimes we have to be very crafty on how we figure these things out, especially when it looks really odd like that, where it's a positive multiplication and a negative number. That gives you a hint it's two negatives. So we have x squared is our first term. 4 is our last term. We use -1x and -4x. Now, it took me years to figure out how to do this right, and I finally figured it out. So this is really a -4. All right, that's super important. That would took two negatives to make that positive. So we need to note that, because we need to pull out a negative right here, a -4. And we need to pull out a negative here, a -1. We might be very confused if we put the +4 here. So it took me years to figure out a system where I could keep track of this box and make it seem right. And that's the new system. So there you go. This one, they just have an x in common and an x in common. And remember, I always just said, just put a plus right here. Okay, but we know plus and minuses, when they're together like that, that's just a minus. So this is going to factor as x minus 4 times x minus 1. So that equals 0. So what that means is x minus 4 equals 0. So we add 4 to both sides. And we have x equals 4. And x minus 1 equals 0. And x equals 1. Okay, so we have just found the solution. So the solution is 1 and 4. Okay, so that means 1 and 4 are the solution to this problem. Believe it or not, they both make this problem work. All right, so now we get to the example, which has made me have to record this. This is my third time recording this lesson, by the way, because of this problem. Okay, so the reason being, and this is a long problem, but I found something, but I didn't answer the question. So let this be a lesson to you. Read the question. It says, find the original price per kilogram. Okay, so my original video, I found the kilograms, the original kilograms, but then I didn't go and find the original price. So that has made me have to record this 3 times. So please read what the question is asking you to do. All right, so let's read the question. So Ms. Ford spent $300 to buy tea leaves. If the price of the bag had been reduced by $50 per kilogram, she would have bought a ½ kilogram more. Find the original price per kilogram. So one of the reasons why I made a mistake is I didn't say what my X was. So X is T in kilograms. So when I find X, I need to understand that that is not the price per kilogram. That is just kilograms, okay? Then I'm going to set this up dollars over kilograms, excuse me, for my proportion. So I have $300 here, and I have X down below. So X is the kilograms that I bought originally with my $300. But then it's saying, well, if the price was reduced $50, I was able to buy a ½ kilogram more for my original $300. So if I subtract this dollars per kilogram minus the reduced price dollar per kilogram, I would get $50 per kilogram because that was the difference between those two. All right, so now we do the math, the other math. I mean, this was hard enough to figure out how to set up, I agree. So let's figure it out. So we have to do a fraction buster and get multiplied by the denominator. And so that's 300 over x minus, and then we do the same thing, x plus 0.5 times 300 over x plus 0.5. Then we have 50 times x plus 0.5. All right, so we can see right away what we can cancel here. Okay, these x's go away. These x plus 0.5s go away. We have no denominator. Happy days. Okay, so now we distribute. So we have 300x. And then half of 300 is 150. This 0.5 is the same thing as 1/2. This one, we just is 300 times x. So we have minus 300x. Over here, we have 50x times x, which is 50x squared. And 50 times x times 1/2 is just half of 50 is 25. So 25x. So just get in your mind that 0.5 is 1/2, okay? 1 is a whole, 0.5 is 1/2. Oh, look at this. So we have 300 minus 300. Bye. Life is good. And then we just have to subtract 150. So we have 0 equals 50x squared plus 25x minus 150. All right, I don't want to deal with that. So I am going to do another little ninja move and divide everything by 25 because I refuse to deal with numbers that big. So bye all big numbers. I'm even going to divide 0 by 25 because what is 0 divided by 25? That's right, it's just 0. And then there's 2 25s and 50. There's only 1 25 and 25, and there are 6 quarters and $1.50, or 6 25s and 150. Hey, look at that. That's nice. See? Got to learn your little ninja moves. Okay, so A, this is a B, and that's C. So A times C is 2 times negative 6, which is negative 12. And B is just 1. So what is 1 apart but multiplies to be negative 12? So that would be 3 and 4 multiply to be 12, and they're 1 apart, and it's positive, so that means the 3 has to be the negative 1 to make negative 12. So negative 3 times 4 is negative 12, but negative 3 plus 4 is 1. So now what we're going to do is the box. So we have 2x squared here. We have negative 6 here. We have negative 3x, and we have 4x here. So 4 and 6 share a 2. They have a 2 in common. 2x squared and 3x have an x in common, and 2x squared and 4x have a 2x in common, and negative 3x and negative 6 have a negative 3 in common. So there we have it. So this is going to factor as x plus 2 and 2x minus 3. So that means that's 0 or that's 0 or they're both 0. So let's figure out what we've got. So we have x plus 2 equals 0. We subtract 2, and we get x equals negative 2. Hold on there. Can we have a negative weight? Can something weigh a negative kilogram? I don't think so. I think this is a bogus answer. This is a bogus answer, so we are going to write extraneous. So that's the fancy math word for bogus. So that means it's just a random number that comes up, because sometimes in math, other things say, yes, that's an answer, when it actually is not. Okay, so now you know, even in math, there are things that try to fool you. And that is trying to fool us. So we have to think about our answers that we get. So now we have 2x minus 3 equals 0. Plus 3 plus 3. And we have 2x equals 3. Okay, so I'm going to use a multiplicative inverse to get x by itself. And I get x equals 3 halves. Phew, I have a positive kilogram. So that's the kilograms. Oops, can't write kilograms on a curved corner. Kilogram. Okay, so that's 3 halves kilogram. Okay, that's what I stopped with last video. But did I answer the question? Look, it says find the original price per kilogram. I have not answered the question. I cannot stop. So I look at, oh, hey, here's the original $300 per kilogram, and that's what I'm trying to find. Hey, what if I take the original money that I had and divide it by the 3 halves, so that's dollars, 3 halves kilograms that I originally bought, and I can get the original price and answer the question the way it was supposed to be answered. So this is 300 divided by 3 halves. Okay, so we're going to keep change flip. So 300 times, we're going to change here. Okay, so that would give us 600 over 3. And then we know 600 over 3, that's 200. So it's $200 per kilogram. So that was dollars and kilograms down here. So after all this fabulous work, we are putting the answer down. The right answer. The original price is $200 per kilogram. There we go. All right, so remember, answer the question. After you do all your brilliant work, answer the question. Excuse me, answer the question. All right. So here we go. Last problem of this video. Okay, so a cyclist cycles at a constant speed from P to Q, a distance 60 kilometers apart. He finds that if he increases his speed by 3 kilometers per hour, he would take 40 minutes less. Find his speed. So if we say speed or rate is distance over time, but we need to set this up as time, so we're going to say time equals distance over r, or speed. Distance over speed gives you time. So the original distance, which does not change, is 60 kilometers. Originally, he went at r speed, but then when he increased r speed by 3, the difference between these two speeds was 40 minutes. But hold on, he was going kilometers per hour, and this was 40 minutes. So we have to express this in terms of hours. So we divide by 60 minutes per hour, and we get 2/3 hours. So now, if we are lucky and think clearly, we can set the equation up like this. All right, so now let's solve this well set up equation. Okay, so we're going to multiply by this denominator. So I have r plus 3 times 60 over r minus r times r plus 3 times 60 over r plus 3 equals 2/3 r times r plus 3. Okay, so that's what we're working with. I'm going to put this other board aside. Okay, so we first see we can cancel out these denominators. Boom, goodbye. No more denominators. We don't like those things. Okay, so then we distribute the 60. So we have 60r and 3 times 60 is 180. Then we have 60r here, but it's minus 60r. And we have 2/3 r squared when we distribute this whole thing to both, plus 2/3 r times, and I'll just write that 3/1. All right, so time to cancel. We have a positive 60r and a negative 60r. Goodbye. We have a 3 on the bottom and in the denominator and a 3 in the numerator. Goodbye. All right, so we have 180 after the smoke settles. 180 equals 2/3 r squared plus 2r. Now we subtract the 180 from both sides using an additive inverse. And we have 0 equals 2/3 r squared plus 2r minus 180. I am not going to deal with a fraction here, so I am going to multiply by the reciprocal, 3/2 and 3/2. But we know 3/2 times 0 is just 0. But 3/2, so 3/2 times 2/3 just has a massive cancellation war going on. And it just equals 1. So I have freed this from a nasty fraction. If we look at 2/1 times 3/2, the 2's cancel, so we just have a 3. So this term now becomes plus 3r. Okay, so half of 180 is 90. 90 times 3 is minus 270. So now we have a new equation. So we have A, B, C. So A times C is 1 times negative 270, which gives us negative 270. And we have 3. So, my goodness, that's going to be tough, huh? Trying to figure out, well, what multiplies to be negative 270 and adds to be 3? The numbers are very close together. Well, I can't think of anything right now, so I'm going to try a negative 10 and a 27 because that multiplies to be negative 270. So at least it gets the paper not white. We don't want a white paper. We want some work on it. So when we add these two together, we get 17. Well, that's definitely not 3. So, but this gives us a chance to do some prime factorization. So 10 is 2 times 5, and 27 is 3 times 3 times 3. So we just tried 10, and that didn't work. Okay, so let's try 15. So if I had a negative 15, so what's left over in these factors is 2 times 3 is 6. 6 times 3 is 18. And look at that. Those are 3 apart. We found it just by doing prime factorization of what we first guessed. So we can write negative 15 here and 18 here. Okay, so let's do a box and find out how fast the cyclist is going. So we have the first term's r squared. The second term is negative 270. We have negative 15r and 18r. Okay, this a is in my way right here, so I'm going to move it. So this factor, we know 18 goes into 270. We have an r here, so r plus 18. This is an r, and then we have plus, and then we have a minus 15. Okay, so this is going to factor as r plus 18 times r minus 15. Okay, so we have r plus 18 equals 0. We subtract 18 from both sides. And we have r equals negative 18 kilometers per hour. We say, wait a second. Wait 1 second. Can you go negative kilometers per hour? No, this is bogus. This is an extraneous solution. It just happened to come up because of the numbers, but it makes no sense. Okay, so then we have r minus 15 equals 0. We add 15 to both sides. We have r equals 15. Say, that one makes sense. You can go 15 kilometers per hour. So we go back to the original question and we try to make sure we answer it so we don't have to redo the video for a 4th time. So we say, find his speed. Well, this speed was 15 miles per hour, or 15 kilometers per hour. But then when he increased his speed here, so this speed here was 15 plus 18, so it's, or 15 plus 3, which is 18 kilometers per hour. Okay, so that's how fast the cyclist was going. And that's how you solve it. And I hope that you have a wonderful day and you always use pencil because we all make mistakes. Bye.